what's up? Welcome back to another very exciting tutorial. Today, we will explore a simulation technique to create some organic effects in Cinema 4D. I know what you're thinking. Organic effects with Cinema 4D? No way, my friend. Use Houdini instead. Well, you will be surprised at what's possible with some simulation techniques in Cinema 4D. I recently had to create an animation for a client to simulate how information is transported through nerve pathways. Nerve pathways have some tricky aspects. They are interconnected, they have some subtle movements in space, so it's not an easy task to start with. Then I came up with the idea of using a rope simulation. To simulate the transfer of information through nerve pathways, I decided to create an additional animated material and use a mospline modifier to apply the material on top of the nerve pathways. So, without further ado, let's get started. Okay, so first of all, we are going into the top view and draw a simple spline. Okay, we're going out of the top view again and change the type of the spline to a linear spline, subdivided, and the angle of 1 degree and a maximum length of 1 centimeter. Then add a cloner object and put the spline into the cloner, change the mode to linear and the count to 70 and the per step length of the y-axis to 1.7 centimeters. So that looks perfect from my point of view. And working with simulations and a cloner, it's always good to have a connect object and put the cloner inside the connect object itself and leave everything on default. Then we add a simulation tag, the rope simulation tag, on the connect object itself. And when we play it, then you can see the whole object is falling down. So we change the simulation, the scene, the gravity to 0. And then we can add a field force object. In the field force object, we add a randomize field. And in the randomize field, we choose the noise type Perlin, change the scale to 150%, give it a little bit of animation speed of 25%, and choose a loop period of 250 frames. And we are good to go for the next step. Change the velocity type to set absolute velocity and the strength to 10. So, yeah, it looks very promising. You can see a lot of wrinkles. We can disable the display box so it is not disturbing our display field. Let's play it again. Yeah, from my point of view, it looks promising. Well, we can increase the depth of the noise itself. So we go into the field force, into the object and the randomize field, and change the relative scale on the z-axis to 200%. So it gives us a little bit more depth on the animation itself. Yes, looks much better now. And let's save the project. Okay. And now we can add a camera. I choose a redshift camera with a focal length of about 50 millimeter. Do some adjustments. And we are good to go for the lighting setup. I usually prefer to create a 3-point lighting setup using a light null object, with each light pointing towards this null object, which has a target animation tag attached. I have a tutorial that explains this setup in more detail. You will find the link in the description below. So I will fast forward through these steps and we will meet back in 2 minutes after the lighting setup is done. Okay, we are back and let's do a little bit of housekeeping. Select all the lights and put it into a null object, into a group. So after that, we can concentrate to render the whole thing out. We're using redshift and put a redshift render tag on the connect object itself. In the curve tab, we change the mode to capsules, or no, not capsules. We are using cylinders, and change the scale to preset, and we load a Gaussian preset in there. So change the scale a little bit down. Okay. And now we can try to render it out on the redshift. I've prepared a special work plane for the tutorial, and where you can see the redshift render itself, and activate our redshift camera, and now you'll see it's working. Okay. But when you look closely, then you can see that the spline itself doesn't have enough geometry to render it very smooth. So therefore, we are going into the redshift render tag again and change the tessellation, the geometry, so that there is much more geometry on the spline itself. So you can see this wrinkle is not smooth as it should be. So we are going into the geometry, override the geometry, and enable the tessellation, leave anything on default. And now you can see it is much more smoother. The wrinkles are much more smoother. We can now change the camera perspective a little bit and play with the focal point and the aperture, so that we have a very smooth depth of field. Change the depth of field, and now we see we have a very cool picture of the nerve pathways. So the right position with the camera angle and the right aperture and a very cool depth of field looks very promising. I love this, but without the right material, it doesn't look good either. So I prepared a material for the nerves pathways, and let's see, it's more or less a standard material with some modifications in it. I have the base color and the reflection, set the reflection of the roughness to 0.5 and the IOR to 1.6. I have the transmission with a slightly changed color and a scattering color also a little bit with that depth of 6, and a subsurface scattering with 2 different colors and a weight of 0.5. So let's put the material on top of the connect object and render it out. Yeah, looks very promising from my point of view. And change maybe the camera angle and start the animation itself, so that we have a very good wrinkle where we can concentrate the next steps. Okay, let's render it out. Yeah, looks promising. From my point of view, the light is a little bit too intense, so we are decreasing the intensity from 5 to 4. Yeah, much more better. And now let's concentrate to make the animation of the information through the nerve pathways. Since we will be using different materials with animation and various texture maps, it's not very easy to recreate this quickly. So you can download the entire project file, which includes different camera animations and lighting setups, for just $5, and you will find the download link in the description below. If you like this tutorial, then please give me a thumbs up and leave a comment, and please subscribe to my channel. I would be very happy to stay in contact with you. This could be done with an MoSpline object. So I integrate a MoSpline object and change some parameters. I go into the MoSpline object and change the mode to spline. And there we have a new tab. And in the spline, we are going to add the connect object into the source spline, change the width, and in the object itself, we change the force mode to include all the forces from our simulation. There we can change the grow mode from the complete spline to the separate spline. We are using a second material on top of the Mo spline. So in order to render this, we can copy the redshift render tag from the connect object and put on top of the Mo spline another material. This material is a standard material with an emission of 3 and with a different color. So it has an orange color. And the secret is the maximum noise, which is integrated into the opacity channel. It has the noise type itself is a Boolean noise type, and we are animating the noise type with an offset. Let's see, on the frame 0 we have an offset of 0, and on the frame 250 we have an offset of 6, so it is slightly animated. And we can see this animation is changing the Mo spline, and it's scrolling from right to left. Let's see that we can, if we can see this much more better. So let's see on the animation itself. Okay, let's render it out. So we have to decrease in the Mo spline, we have to decrease the size of the spline itself so that the spline itself is not overwritten. So therefore we are going into the curve and change the thickness to 0.5 so that the other nerve pathways are rendered out with the original material. So you have the nerve pathways with the material 1, and on top are the Mo splines with the material 2. And the material 2 is more or less an emission tag, is more or less a material with an emission, and is animated from right to left with an maxon noise. So you can see when I play it through, there you can see that the noise is changing from right to left. And with the right camera angle and the right aperture and the right depth of field, you have an absolutely wow effect of the nerve pathways integrated with the simulation of the information which are going through the nerve pathways. So you can see this looks very promising. And let's play with the camera a little bit and the depth of field. This is more or less a big secret of this project, to play with the right camera angle and the right aperture to have an absolute stunning wow effect of this. So you can see it looks very promising to have the right aperture and the perfect depth of field. So when we render frame per frame, then you can see that the information itself is going through the veins. It's just a simulation, but it looks very promising. So let's put it a little bit further, the next frame, and there you can see that the information is going through the wrinkle itself and leaves the wrinkle on the other end. Yeah. So maybe we can tweak a little bit the emission. Let's do it a little bit of more saturation, a little bit more orangey. So, and there you can see Wow, looks absolutely stunning. So maybe we can change also the settings of the render settings, do a little bit of bloom effect, change the bloom threshold and the intensity, and also the bloom softness a little bit. And now, wow, we have an absolute perfect and stunning wow effect of the nerve pathways with simulation of the information which are going through the nerve pathways. I love this. Let's change the render size to see it much more clearer. I think the materials are also very important, to have the right materials. And when we change the camera view again and do another render of this, maybe on this side, and yeah, change the focus again, change the camera angle, the aperture and the depth of field, and now you have an absolute stunning wow effect. Yep. So I think the secret of the whole thing is the materials at the right camera angle with the right aperture. Yeah, looks promising. I love this. And now you can see again the information which are simulated through the nerve pathways, which are going from right to left through the wrinkles. And yeah, looks absolutely promising. I love it. Okay, that's it. It's a lot of fun working with different simulation techniques in Cinema 4D. There are endless possibilities, especially when you combine it with other simulations like gloss simulation, fire or smoke, or consider the new particle system built into Cinema 4D. So thank you for watching. Again, if you like this tutorial, then please give me a thumbs up and leave a comment. And please subscribe to my channel. I would be very happy to stay in contact with you. And we will see you next time. Bye.